Hello students, in today's session of alternating current, concepts of current and potential relations will be clear through illustrations. In earlier session, we have gone through this. That is, what is mean value, what is RMS value, what is instantaneous, what is peak value, how they are related with the mean value, which you can review on Sethi Swift Learn. In today's session, I am going to discuss phase relationship, between V and I in case of pure resistance, pure inductance, pure capacitance, and also through illustrations, concept will be clear. It is requested go through the complete video, going to be very helpful for CBSE board and other entrance exams. Let's start with the concept and questions. Concept regarding relation between V and I for alternating supply source. Let the alternating applied EMF to an AC circuit is E equal to E naught sin omega t. Number of cases may be there. Circuit may be containing pure resistor only. Circuit may be containing pure inductor only. Circuit may be containing pure capacitor only. It may be combination of any two or all the three. Right? Number of cases are there. First of all, we discuss pure resistor is connected only. In that case, same phase means both are varying in the same manner. Both are becoming zero at same time, attaining their positive maximum, negative maximum values at the same time. The current and voltage across phasor rotate together. They are parallel to each instant. The projection of vertical axis represents their instantaneous values. The detail of this is going to be discussed in the question, right? Means when this is applied, then I will be equal to I naught sin of omega t. I naught will be equal to E naught by R. I and V both are in same phase. Detailed in the next question, right? When containing pure inductor, voltage and current are out of phase or out of phase by quarter cycle, or voltage peaks occurs at a quarter cycle earlier than the current peak. Means in case of inductor, you should keep in this mind. So this is I, this is VL, this is VC. This is VC. So voltage leads the current. Voltage leads the current by 90 degree, or you can say current lags the voltage by 90 degree. Quarter cycle means you know P equal to 2 pi corresponds to lambda. These are the relation between time period, phase angle and distance. If one is sine wave, this is 0, pi, 2 pi, this comes out to be pi by 2, this is 3 pi by 2. In terms of time period का लिखेंगे, this is t, this is t by 2, this is t by 4. Therefore, it is using quarter cycle. Pi by 2 means quarter cycle. So, if E equal to E naught sin of omega t, then I will be equal to I naught sin of omega t minus pi by 2. Current lags the voltage by 90 degree. To make the comparison, both terms should be of sine or both terms to cos. Omega t term is to be made positive by using the trigonometric property. And here I naught equal to E naught by XL. XL equal to omega L. Omega is 2 pi L. That is known as inductive reactance. Its unit is ohm. Right? This is also going to be discussed in the next question in this video. When capacitor, the capacitor voltage and current are out of phase by quarter cycle by 90 degree. The peak of voltage occurs quarter cycle after the corresponding. Means if E equal to E naught sine of omega t, I will be equal to I naught sine of omega t plus pi by 2. That is, I naught will be equal to E naught upon xc. X is equal to 1 over omega c. That is known as a capacitive reactance. Detailed derivation is going to be discussed in the further video, right? Its unit is ohm. The reciprocal reactance is called substance and that of impedance is called admittance. Impedance term is used when XR difference XC whole square. That is the impedance. This will discuss in the next video, right? Now let's start with the question. Question is, show that in an AC circuit containing a resistor only, current and voltage are in same phase. Now let this will be equal to E naught sine omega t. Applied AC sources E equal to E naught sine of omega t. This is equation 1. Now, potential difference developed across the resistor will be equal to V equal to I into R. V equal to I into R. That is, IR will be equal to V, that is equal to E naught sine of omega t from 1. Therefore, I equal to E naught by R sine of omega t, that is I naught sine of omega t. I equal to I naught sine of omega t. That is I naught peak value of current, that is E naught by R. This is the instantaneous current. This two. Comparing equation 1 and 2. That is E equal to E naught sine of omega t and I equal to I naught sine of omega t. Means this is exactly same. Exactly same means E and I are in same phase. Here is the E is instantaneous EMF and E naught is the peak value. Same phase means both E and I attains the zero value at the same time and also attains maximum values and minimum values at the same time. That is the meaning of same phase. Graphically is shown here. This is 0, 0, pi, 2 pi. Attaining maximum at the same time. As we know, T corresponds to 2 pi corresponds to lambda. That is time, phase angle, that is wavelength, distance. They are related by this formula, right? So they are attaining the same value at the same time. Zero value at the same time, maximum value at the same time, minimum value at the same time, and similarly all other values, right? That is the meaning of same. This is the graph between E and O. This is the sine wave. Sine wave. This is known as sinusoidal. Sinusoidal. One is phasor diagram. Purely resistive means E naught and I naught. This is E naught and I naught are in same phase. Are in same phase. Means phasor diagram. Phasor of E naught and I naught rotate simultaneously. Same. Means at the same time. If you rotate like this, rotate like this. This will be the E naught, this will be the RMS instantaneous value. This is the instantaneous current. Right? This is all about the when pure current flows through the pure resistor. Right? Now, next question. Before start of the other question, I would like to say this. The videos available on Sethi Swift Learn YouTube channel, which are concept killing videos. Concept killing videos. Very, very useful for +1, +2, NEET, JEE, and other entrance. Very, very useful. Please review it on Sethi Swift Learn. इसी के साथ साथ मैं आप लोगों से रिक्वेस्ट करूंगा कि अगर अभी तक आपने YouTube चैनल सेठी स्विफ्ट लर्न सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद colleagues and friends. Now let's start with the question. Question is, show that in an AC circuit containing inductor only inductor, current lags the voltage by 90 degree. Let the AC voltage connected through an inductor E will be equal to E naught sine of omega t. This is the sinusoid. This is equation 1. This is the instantaneous voltage. This is the peak voltage. Omega is the 2 pi f equal to 2 pi by t. Right? Standard values are there. Now, EMF induced across the inductor will be E equal to minus L di by dt. Rate of change of instantaneous current. Right? Therefore, EMF induced across the inductor is E equal to L di by dt. Then E will be equal to minus L di by dt. That will be equal to E naught sine of omega t. Sine of omega t. L di by dt. This negative sign shows reflection of Lentz's law. That is, it opposes the very cause producing it. Right? L di by dt equal to E naught sine of omega t. Now we have to find the expression for I. So keeping di on the left hand side, E naught by L sine of omega t. If we integrate both sides, dt. If we integrating both sides, So di E naught L is a constant taken outside the integration sign. Sine of omega t dt. Integration of sine ax plus b equal to minus cos ax plus b divided by coefficient of x, that is a. Right, so I will be equal to E naught by L minus cos omega t upon omega. Right. On further simplification, that is E naught omega L with minus sign cos of omega t. This omega L can be written as XL. XL is a inductive reactance. Inductive reactance. Inductive reactance. Right? So this comes out to be I equal to E naught upon XL denoted by XL. Introducing the sign, इसको लिख सकते हम sin of omega t minus pi by 2. You know, sin of minus theta is minus sin theta. Sin of minus theta is minus sin theta. So this comes out to be this one expression. This expression can be written as this. Reducing this into sin, because we have to compare with the applied EMF. That term is sin omega t. We have to reduce this term into sin with certain phase angle. This is comes out to this one. Sin pi by 2 minus omega t is cos. That comes out to, but minus sin is there, so we have to take omega t minus sin common लिया, ये निकल आया हमारा आंसर. ठीक है. Now comparing equation 1 and 2. Comparing equation 1 and 2. Comparing equation, this is equation 2. Comparing equation 1 and 2. E equal to E naught sin of omega t and I equal to I naught sin of omega t minus pi by 2. Where I naught equal to E naught over XL. XL का unit ohm. XL का unit ohm. That is sin of omega t minus pi by 2. So from this it is clear that current lags the voltage by an angle pi by 2. Right? Now this is the graph. Means at t equal to 0, at t equal to 0, equal to, this is the sine wave for EMF. This is the for instantaneous current. So it is lagging. So it is lagging. When it is maximum, it is comes out to be 0. When EMF is maximum, current is 0. That is lagging by pi by 2. That's the end, right? And next is phasor diagram. Phasor diagram is, this is E naught applied EMF omega t. Now this angle is, so I naught lagging the EMF by 90 degree, this is 90 degree angle. This is the ground here. So this is the instantaneous EMF, this is the instantaneous current. This is all about the inductor phase relation between the V and I. Right? Next question. Question is, show that in an AC circuit containing capacitor only capacitor C, current leads up voltage by 90 degree. This is the capacitor, this is the applied EMF source. That applied EMF source equal to E naught sin of omega t. This is the instantaneous value, this is the peak value, omega is the angular frequency. As the capacitor is charged and discharge alternatively as current reverses at every half cycle, right? Therefore, let at any instant t, the charge on the capsule plate, charge on the capsule plate B, charge the capsule plate B Q. Then you know potential density equal to Q by C. Now V equal to Q by C, that is equal to E, that is equal to E naught sine of omega t. Q will be equal to E naught into C into sine of omega t. Right? Now to find I, differentiate, इसको differentiate करना पड़ेगा dq by dt. तो differentiating both sides with respect to t. So dq by dt equal to C naught into sine of omega t into coefficient of t. Integration में अपॉन में आ जाता है, that comes out to be omega c E naught sine of omega t. Sorry, that comes out to be cos of omega t. Sine के differentiation cos of omega t. Right? Now we have to apply Ohm's law here. E naught upon 1 by omega c. Cos को लिख सकते हैं sine of omega t plus pi by 2. So this is E naught xc, that is sine of omega t plus pi by 2. Now this comes out to be I. X is the capacitive reactance. Capacitive reactance Xc equal to 1 over omega c. This comes out to be I equal to I naught sine of omega t plus pi by 2. So this is equation 1. Comparing equation 1 and 2. 1 and 2 comparison करेंगे, then 1 is E equal to E naught sine omega t. E equal to E naught sine of omega t. This is 1. On comparison, we have to make first of all both terms sin और sin की बनानी पड़ेगी, cos है तो cos की बनानी पड़ेगी, दोनों को sin के बना. Then omega t को दोनों साइड में पॉजिटिव बनाना पड़ेगा, उसके साथ जो एंगल आता है प्लस आता है माइनस आता है, using the trigonometric formula, convert this into that, right? In this case we see omega t, this is advanced by pi by 2, means I leads the V by 90 degree. This is clear? Now this is the graph. This is the simple sine wave at t equal to 0, but at t equal to 0, I will not be equal to 0. It will be advanced. So this is not 0. This is given at t equal to 0. This is the meaning. Complete the sine wave, right? This is the graphical. इसको practice कीजिए draw करने की definitely, right? One is phasor diagram. This is the phasor diagram. Phasor diagram में this is the E naught omega t. अब करंट लीड्स द वोल्टेज, तो दिस इज pi by 2 ड्रॉ कर दिया. ये स्टैंडर्ड है. एक बार करंट को इधर ले आएंगे प्योर इंडक्टर के केस में, एक बार पे रहेगी सेम, एक बार इधर चली जाएगी. दैट इज फॉर आर एल एंड सी केसेस. This is all about capacitance, right? Now, I would like to request, if you are new to my YouTube channel, Sethi Swift Learn, Sethi Swift Learn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.